and you'll say, that looks like this test would be best for this. So there are certain tests that we like, oh yeah, when we see this, do this test. All right. So when we look at the two series that we have so far, geometric and harmonic, there's only one type right now that I actually know an answer for, right? Harmonic's going to diverge, so that never adds up to anything. It's divergent. Geometric could diverge or it could converge. It converges when r, absolute value of r, is less than 1. In that case, I get an answer, right? A over 1 minus r. Yeah? So right now, there's only one series I can actually find a sum of. And that's a geometric series with absolute value of r less than 1. Now I'm going to show you a different type of series, which we, again, will be able to find the sum of. It's called a collapsing or a telescopic sequence, or series. Telescopic or collapsing collapsing series. It goes by both. This book uses telescopic. Let me do the problem first, and I think you'll see why. Okay? I don't want to give it away yet. Yeah, because you may be like, what's the relationship between telescopic and collapsing? All right. Good question. All right, so I'm going to give you the series. You ready? Here it is. What is sum n equals 1 to infinity of the natural log of n over n plus 2? All right, so the first thing you do is run the nth term test, right? I should put here, this is example. I want to know if it converges or diverges. Is that all right? Okay. So run the nth term test. I'm going to write that down. I'm going to tell you what I'm about to do. Nth term test. I'm going to take the limit as n goes to infinity of natural log of n over n plus 2. What am I hoping for? That this is not 0. If this is not 0, I'm done, right? Here you go, you pass the limit inside the log, okay? Infinity over infinity, L'Hopital, 1 over 1. So the inside is just 1, right? Is n goes to infinity, this thing goes to 1. You all follow? And natural log of 1 is 0. Test fails. Done. I've given in my classes before, I've given a quiz where I walk in and I hand them a quiz, one question. And it's like, something like, I forget what I've done, but I think it's something like this. And they say, and just to see what they say, like what my class will say, and basically everyone gets, a lot of people still get it wrong. They say, okay, this goes to 0, this series converges. That's not the case, right? This may converge, it may diverge. We don't know yet, right? We still don't know anything. All right, so why is this special? Why is it different? Why are we going to be able to handle this? Well, anybody recognize something in there that I might be able to do here? Oh, you know what? Let's do this before I get you to recognize. Let's write this series out. This is natural log of, like let n be 1. You get 1/3 and then plus natural log of 2/4 plus natural log of 3/5, right? Plus dot, dot, dot. That's what this series is. I'm trying to figure out what this adds up to be. It might diverge. It might just get bigger and bigger and bigger. Maybe not. Would everyone agree that each one of these is getting smaller and smaller and smaller?
Yes.
Right? Because we said this was headed towards 1. Natural log of 1 is 0. So we know that those are getting closer to 0. But we've seen that just because it goes to 0 doesn't mean it converges. Harmonic diverges, right? So what else could I possibly do here? Think college algebra.
Put all together.
How?
No, that's something.
Can you make them multiply by just for addition? Like natural log of all that.
Of this times that. Yeah, we could do that. Before we do that, though, come over here. What can you do if you have division inside of a natural log? Make it subtraction? Could I make this then the same? This would be exactly the same series. Do you agree? That's the same series? Just looks different. I'm using a property of logs there. Now start writing things down. I get natural log of 1 minus natural log of 3. That's the first thing when I plug in 1, right? Then plus, now plug in 2. Natural log of 2 minus natural log of 4. Plus, next one, natural log of 3 minus natural log of 5. Plus, maybe one more, natural log of 4 minus natural log of 6. Plus, dot, dot, dot. Anybody see anything going on here? How do you mean? Well, you can't put these together, though. You can't put those two logs. You could do back to division, but then you'd be back up to this. Something else. 1, 3. Yes, I do see that pattern. Yeah. But it's something else I want to see if you recognize. So I think there's a lot of patterns here, right? But there's something They're all natural logs, yes.
They're canceling out
What's canceling out?
every time you go over 2.
Yeah, look at this. This is negative natural log 3, isn't it? Now, I don't need the parentheses there, do I?
No.
No. And over here, this is what?
Plus,
Positive natural log 3. So those two are going to kill each other off, aren't they?
right.
These are gone. Does that happen anywhere else?
4.
Negative natural log 4 will actually cancel off with natural log 4. Does it happen anywhere else? It would. It would continue, wouldn't it? Negative natural log 5 should cancel out with the next one that would have been here, right? So that one should go away because of something downstream here, right? How about negative natural log 6? Same thing. This is going to go away because of something downstream there. And am I ever going to run out of anything downstream?
No.
No, because it goes forever, right?
So we have 1 plus 2.
So what appears to happen here is that I'm left with this one and I'm left with this one, right? That's kind of what I'm picking up here is that's what's going on in this infinite series. The problem is, though, I know that these keep on canceling with something further downstream, but what about, like if I ever stop, right, I won't have something downstream anymore to cancel with, right? Like if I ever stop. So we're on the right track here, okay? We're on the right track, but this is not going to be the way we get our final result. This is just for us to see what's going on, all right? So let me continue this. I want to remind you, though, recall, we said that a series converges to sum S, all right, we would say that a series converges to S if S sub n converges to S. And S sub n, did anyone remember what S sub n was? The nth partial sum. This right here was the nth partial sum. I showed you that in class. What we meant by that is this. This might ring a bell. I came up, what we did is we did partial sums. So like if I gave you a sub n equals, let's just do n, right? Then if I do the sum of that, that would be sum n, which would be 1 plus 2 forever, right?
It's like the bonus you guys.
Yeah, that is. Right? What is the nth partial sum? What's S sub n? It's 1 plus 2 plus 3, but I don't go forever, actually stop where? At n, right? So the nth partial sum means we add up the first n terms. That's what this is. We take the limit as n goes to infinity, and that goes to s. So what I'm going to have to do this correctly is I'm going to have to look at the nth partial sum. If you're like, what the hell is he talking about? Well, that's why I record my lectures. Go back and look at it. All right? So we are going to look at S sub n. S sub n for us is the sum, now be careful here, k equals 1 to n of natural log of k minus natural log of k plus 2. So does everyone recognize that's the same formula we just had? But I'm using a dummy variable of k instead of n because I'm stopping at n. So y'all see that? All right, let's write this down. And I'm going to need a lot of room, okay? I'm going to start out. What happened when we plugged in 1? We had ln1 minus ln3. When I plugged in 2, ln2 minus ln4. Plug in 3, ln3 minus ln5. Plus, I'm going to do one more, ln4 minus ln6. With me? I continue this, not forever this time. I'm actually going to stop where? At n. So way here at the back, what would the last one be if I stop at n? ln n minus ln n plus 2. Right? That's what would happen if I stop at n. With me? What is the one that would be right in front of that? So this is what happens when I'm at the nth one right here, right? The one right before it would be n minus 1. So tell me what happens if I plug n minus 1 into this? Natural log n minus 1 minus n minus 1 right here. And minus 1 plus 2 is n, what? Plus 1? Do y'all see what I did there? I'm plugging in n minus 1 wherever k is. What's the one right before that? This will be the last one I do. Okay, so it'll be natural log of n minus 2 and then minus what? Natural log n. Do y'all follow what I'm doing? No?
You started it before, right? It's the nth time.
Yes, because it's easiest to start at the end and work my way backwards than it is to start at n minus 2. Okay, do you all see that this is the nth partial sum? This is me just adding up the first n. I'm going to take the limit as n goes to infinity on this, but not yet. I'm going to get any canceling done that I can, because I recognized earlier that there's canceling that happens. Natural log of 1, I don't see a natural log of 1 anywhere. Natural log of 3, negative natural log of 3. That cancels with? This one gets canceled with this one right here. How about this natural log 2? Does it go away?
No.
No. Negative natural log 4? Yes, that goes right here with this one, right? Gone? Okay, so that's gone, that's gone, that's gone, that's gone. What's the next one that would cancel? Negative natural log 5 would cancel with something right here, right? Agreed? In my dot, dot, dot in here? Somewhere in there? How about negative natural log 6? Would that cancel with something over here, right? In that dot, dot, dot still? Y'all following that? Okay, so I would like for us to recognize a pattern. This is my first result when I plugged in 1, right? This is my result when I plugged in 2, plugged in 3, plugged in 4. So my first expression here, the second term, is getting killed off by the first term 2 sums away, right? So that's a pattern. Second terms get killed off by first terms 2 away. So you see this second term right here? It gets killed off by the first one 2 away. This one right here gets killed off by the first one 2 away. This one gets killed off by the first one 2 away. I can't see it here. So what about this second one? Does it get killed off? Yes, by the first one 2 away. So if I look downstream, the first one 2 away should be the same thing. They go away, right? That one and that one go away. See that? How about this second one? Do I have one downstream 2 away? I don't, because I stopped the sum, which means this one does not get canceled. Do y'all see that? This second one doesn't have a first one 2 away to get canceled off. How about this second one? This one does not have anything down here to get killed off. Do y'all see it? So I said the pattern was what again? Second ones kill off first ones 2 away. Could I reverse that and say first ones get killed off by second ones 2 in front? So how about this first one right here? Which one? Right here, this first one. Does it get killed off? First ones get killed off by second ones 2 in front. Is this one going to have 2 in front? Is there a second one? Yes, there is. This one should get killed off by something I can't see in there, right? How about this first one? First ones get killed off by second ones 2 in front. That one should go away also? Do you see now why these two didn't go away? Because you would have to, they're first ones, right? They have to be killed off by second ones 2 in front. There is no 2 in front. This first one, there's no 2 in front. This first one, yes, there was a second one 2 in front. Do y'all see that pattern? I expect to see this on the test. Very important that you write down S sub n is this sum. You write out the sum and you show all these cancelings. Whatever you want to do. You can put arrows to the dot, dot, dot. Yeah, let's do it.
This is on Thursday's test?
No, this is not on Thursday's test. No. This is on the next test, though. Yeah.
Final?
This will be on the final. Okay, so look. What is left? At the end of this canceling, what is S sub n? What's the only thing that's left? Natural log of 1 plus natural log of 2 minus natural log of n plus 1 minus natural log of n plus 2. That's the nth partial sum. Now let's talk about why they call it telescopic and collapsing. Collapsing, the only things that were left were on the edges, right? Everything in the middle, like a bridge, collapsed, okay? And you just bring the two ends together. Do y'all see that? Collapsing. Telescopic goes back to the old school telescopes, the ones where you know they go, they had like a tube inside a tube and they go like that, and then they look through them, and then when they were done with them, they closed them up, right? And the two ends came together. That's the idea behind telescopic. Understand? So that's why they have the two names. That's S sub n. Now what?
put it back into like the original form where you multiply and divide and stuff.
What did I say? I said you're going to have to go back and watch the video maybe. We say that this goes, a series converges to S if S sub n what? Goes to S, right? Which means I need to figure out what this goes to. What does this go to if I let n go to infinity? That's the next step. I take the limit as n goes to infinity of S sub n, which means I'm doing the limit as n goes to infinity of natural log 1 plus natural log 2 minus natural log n plus 1 minus natural log of, I'm out of room here, n plus 2, right? Yeah. Well, let's see what happens here. I think we can get the answer now, but I'm gonna write this in a different way. Oh, plus natural log 2. How about this? Minus, well, you know what? I think we can just do it right there. I just want to get it all on camera, though. Okay, that's where we are, right? Let n go to infinity. What happens? Nothing here, right? Nothing here? Infinity. Natural log of infinity is infinity, right? So this goes to infinity, and then this one goes to infinity. So I have minus infinity, minus infinity. That's still minus infinity, isn't it? If we say minus infinity plus infinity, then we don't know. But if you take a huge negative number and you subtract another huge negative number, it's still a negative huge number. So what is this going to? Natural log of 1 plus natural log 2 minus a huge number. It's becoming infinite, right? Negative. So this sum goes to what? S sub n goes to negative infinity, doesn't it? S sub n goes to negative infinity, which means this series diverges. Therefore, sum n equals 1 to infinity of natural log of n over n plus 2 diverges. Now, what if that had gone to a number? What if that had come out and the answer was like, let's say, natural log 2? That would be your answer. It converges to natural log 2. But that's not what happened here. That's it, yeah. We'll have to do some more of those. I only have a few minutes and then we're going to talk about the test. Let me show you a different one. I'm not going to go through the whole thing. This is one of your homework problems. Sum n equals 2 to infinity of 2 over n squared minus 1. So does this converge or diverge? Well, first thing you would do is the nth term test, right? So if I do a quick nth term, what's the limit as n goes to infinity of 2 over n squared minus 1? 2 over infinity, that goes to 0, which means this test fails. So then I look at it and I'm like, well, is that a geometric series? No, because n has to be the power for it to be geometric, right? N has to be a power. Is it harmonic? Well, harmonic was k over n, right? It was k over a linear expression. Is this linear in the bottom? It's quadratic, so it's not harmonic. So then you can maybe start writing some of these things out. What happens if I plug in 2? Get 2 over let's see, 2 squared 4. We get 2 over 3 plus 2 over, now I'm plugging in 3, right? 9, 8, so 8 here plus 2 over, let's see, 15, and so on and so forth, right?
Couldn't you make it harmonic then?
How?
2 over, since it's a difference of
Yes.
squares, 2 over.
Okay,
this one, 2
I'm
over
with you on that. I'm with you on that. But we do have a little issue. I agree with this. You're noticing that, right? Each one of these by themselves are linear, but when you multiply them, it's quadratic. So it's still quadratic. Unless we could somehow break it into 2 sums, each one being linear. But you won't be able to just do, like, I don't know how you would do the top, but you can't just make this like this. This is not allowed. You can't break a product out like this, a sum out like this. But you're on the right track. How could you turn that into these n plus 1 and n minus 1 separated? That's a drum roll.
Take 2, separate, put 2 over 1, you become the
How?
Partial fraction.
Partial fractions. Very good. Partial fraction decomposition. We did this for integration, didn't we? If you wanted to integrate this, right, you could split that up into 2. So you have to do partial fractions on this now.
If we wanted to split it up, right?
We need to split it up. This is going to be a telescopic series. So it's gonna break up. Do you want me to continue or you want me to talk about test? Test? Continue?
Just this last one, just this last one.
No, it's going to take a while though. This will take us another 15 minutes. All right, let's hold this, and if I don't have enough questions, then I'll come back to it. All right, what about the test? What do you want to know? What, 39 what?
On 7.2, where there's a certain base, the base of cross sections.
All right, let me give you an example of the base of a solid and all that junk, okay? I know which one you're talking about.
Give us 11 circular questions.
All right, so this is beyond what I would ask, but I'll do it. It says that you're given an ellipse like this. And it says that cross sections that are perpendicular, I'll just put perp, to x-axis form isosceles triangles. Right triangles with hypotenuse in the base. Hypotenuse in base. All right. I'll explain what that means. All right, so here we go. We have an ellipse. Do you all know how to draw an ellipse? Do you all know what an ellipse looks like? All right. Let y be 0 and give me the values of x that make that true. If y is 0, kills these off, right? Solve 9x squared equals 36. Plus or minus 2. Right? Square root. So x squared is equal to 4, so x plus or minus 2. So if the y coordinate is 0, your x coordinate is 2 and negative 2. Do you all agree?
Yes.
Okay, now let x be 0. Plus or minus 3. And then, of course, you can just draw this ellipse-shaped egg-looking thing, right? Good enough? Almost like a circle. Okay. This is the base of a solid. So in three-dimensional space, let me see here. if this is the x-axis and y-axis on the ground, this is my ellipse on the ground, roughly, okay? Do y'all see that? That's the bottom of a solid. Well, it says the base of S is an elliptical region with this boundary. Cross sections perpendicular to the x-axis are isosceles triangles, with the hypotenuse being the base. So if I come in here and I take a knife and I cut through and I run perpendicular to the x-axis, so that means I'm really, if this is x-axis, I'm coming through with a knife and I'm cutting into this like this. Then when I cut through that, right there, which would be equivalent to me going here, and I look at a cross section from the side, I'm looking in at the side of it, what I can see form there is an isosceles right triangle with the hypotenuse being the base. What? Okay, so what is an isosceles triangle? Two sides, same length? And it's a right triangle. So this would be an example of an isosceles triangle, right triangle. That side and that side are the same. And of course the hypotenuse can't be the same, right? But this says that when I take this cross section and look at it, this isosceles triangle I get, the hypotenuse is in the base, which means that this edge is the hypotenuse. So if I would do this in color, this hypotenuse in blue must be the edge that's right here. Understand? And then the right triangle comes up from there and back down there, and that's a right triangle. Do y'all see that three-dimensionally?
Yeah.
Paper? Who has paper? Real quick, sacrificial paper. No, just one sheet.
I didn't mean to spiral, it was terrible.
Oh, I thought you were giving me the whole. Thing. So this is an isosceles right triangle. Yeah? Isosceles right triangle. When I cut through this thing, right? And I look at this from the side, I'm seeing this. Isosceles right triangle with the hypotenuse being in the base. So that's what I'm trying to draw here, is that piece. Do y'all see it a little better now? Okay? And if I move this over to a different section, different slice, the only thing that changes is this triangle gets smaller, right? What we're trying to find is the volume of the entire object. So what we're going to imagine is that we're going to take, instead of a slice, we're going to take this infinitesimal